Hi, my name is Matthew Beal, and I am Dr. Richard's teaching assistant for your English 334W technical communication class. I'm going to be delivering the video lecture this week on visualizations, and I'm currently a fourth-year English PhD student at Old Dominion University, where I'm writing my dissertation on technical communication and teaching project management with games in the classroom. You may know me from my greatest hits, such as providing you feedback on your first 2 weekly reading responses and giving you feedback on your introductory memos. So we're going to talk about a couple of things this week regarding visualizations. We'll talk about the functions and characteristics of good visualizations, and we'll talk about planning your graphics based on audience and purpose, and then we'll also talk about what makes good and bad visualizations, and we'll look at a lot of examples to cover those to see, so you can see specifically what to do and what not to do in your assignments. So why do we use graphics? Well, we use graphics for a number of reasons. For one thing, they can help readers to understand complex ideas in text that maybe words just have trouble conveying. So things like spatial information and logical and numerical relationships are ideal for graphics. They can help writers emphasize certain points, so you can talk about something in text, and then you can provide a graphic or an illustration to augment that and to provide an additional perspective on it, an additional way of looking at it. Additionally, they can help communicate with multiple audiences with different interests and reading habits. So, when you're writing a technical document, you have an audience in mind, but you might not necessarily know all of the individual idiosyncrasies of the people who will be reading that document. So, some people might respond better to text, while other people respond better to visuals. And in general, as human beings, we take in and recall the vast amount of our information through visuals and through, we read through sight, but also through some kind of images where we're looking at a photo and we're taking in the entire image at one time. Okay, so let's talk about what makes an effective graphics then. Effective graphics have a number of features and a number of characteristics. First and foremost, they need to serve a purpose, right? So graphics need to be connected to something in the text, and they need to supply more information to some point that you're making in the text. So you don't want to include graphics that are just, photos there to make your document look prettier, because technical documents don't need to be prettier, right? That's for marketing. And so any graphics that you're using need to have some kind of purpose and some kind of connection to help the readers understand and remember information that you're giving them in the text, right? So if you have multiple data points that maybe would be hard for a reader to interpret in a paragraph, you could write a paragraph about your data points, but providing a chart or a table or a bar graph would probably make that much easier for the reader to understand. Second thing regarding effective graphics is that they need to be simple and uncluttered, right? So don't over-design your graphics. I've seen a number of students who will make complicated graphics just because the program can do it. So that's not what this assignment is about, and what Dr. Richards and I are asking you to do. What we're looking for is making sure that you can create graphics that clearly and explicitly convey your data points and your information. So, when you're making a bar graph or a pie chart, you want to use colors that really stand out from one another. So you don't want to use two similar shades of blue, for example. You might want to use blue and then red, blue and orange, blue and yellow. So blue and green are probably not the best choices to put together because, again, those are of the same hue. So if you do need to use blue and green in your pie chart, you probably want to make this one over here blue, then this one red, and then maybe this one over here green, so that those two are not running together, just for the sake of your reader. So keep your charts simple, and keep them, in general, keep them 2D. Don't try to make a fancy 3D chart. Usually 3D charts, while they might look prettier, they can be harder to interpret simply because of that extra depth that is usually unnecessary. So in general, keep your charts 2D. Third, for an effective graphic, present a manageable amount of information. So don't try to cram too much information into one chart. That will make the graphic much harder to interpret for your reader. So you want to, for example, in your visualization assignments, which I'll be talking about at the end of the video, you want to think about how you're using look at one question from your quantitative data, and think about how you would interpret that in chart form or in graphic form. So not too much data. And then on the other side of that, however, don't make a graphic for a simple to understand data point. So if you're talking about like 1/2 of something, or 1/3 of something, or 2/3 of something, those are common fractions that readers will be they'll have no trouble understanding those fractions, and so they probably don't need a graph for that, right? A chart for that. So number 4, so you want to meet the reader's format expectations, right? So readers will come to your graphics with expectations about like how to read a bar graph, or how to read a pie chart, how to read a table, and things like that. So you don't want to try to reinvent the wheel for these things, right? Because again, this is about presenting clear and effective information. You don't want to try some new style of table, or try presenting a bar graph in a way that maybe doesn't make any sense. So think about the bar graphs and the pie charts that you've seen in the past, and what are your expectations when you come to them? How do you expect to be able to read data in those charts? That's what your readers will be looking for as well. So lastly, for an effective graphic, you want to make sure that it's clearly labeled, right? So every graphic that you create needs to have a title, and each area needs to be clearly labeled in some way, whether that is a bar chart or a bar graph, rather, that has a label on the bottom on the x-axis and a label on the y-axis, and or a pie chart where each slice of the pie needs to be clearly labeled. And you want to make sure when you're labeling these things, yes, you'll be using numbers, right? Because you're going to be talking about your survey responses. But you want to make sure that those numbers are clearly understood by your reader. So, you want to say like 5 students said this, or 6 students here. You want to make sure what those numbers are attached to. In this case, it's going to be probably students. But when you're talking, if you've asked students about different, their feelings about technical communication, you need to make sure that each of those data points are clearly labeled and how each one is being represented in the chart. We're going to look at some examples in a minute, and I'll point out some good examples of labeling and some not so good examples of labeling when we look at these. So let's go do that now.
Okay, so here's our first example. This example, the next three examples will be from the National Highway Traffic Safety Administration under the U.S. Department of Transportation. These are about different accident data that they've collected. And while there is some good information there, the way that it's presented is not as strong as it could be. So this first example, talking about crash modes, right? We have the right offset, the full frontal, and the left offset. First of all, so we have the bar graph here that's showing us this percentage. And then we have this table over here that is presenting the exact same information as this. So in this case, we could say that this table is redundant because it's not giving us any new information. It's actually giving us just the exact same thing, so there's really no need for it. Additionally, if you'll recall how I mentioned, 3D graphics are usually not a good idea, right? So the 3D in this case, it throws off the percentage because when you look at the 3D, the question becomes where is the top point, right? Because if you look at it, is it here or is it here? It's not entirely clear. And while you can study it a little bit and you can probably reach the conclusion of where it might be, again, you're thinking about your reader and you want them to be able to interpret the information as fast as possible. So upon closer examination of this as well, thinking about the best way to present this data, right? So we have a bar chart here, and we have this table over here that's doing the same thing. When we re-examine it, this bar chart isn't really giving us any kind of information. We don't need this, this distribution of percentages. We can already understand. We can understand this, distribution of what. Plus, it would be nice if they provided, how many, what is the total number that they're looking at here, somewhere. So in fact, we could probably just do away with this bar chart and just stick with this table, right? It's simple, it's effective, much easier to read and understand and interpret rather than this bar chart. So the next one, we have a bar chart and a line graph. So there's a lot of information here, and it's not presented that well. Again, we have a bar graph and a table here that are showing us the same information. A line graph in this case is not a good way to represent this no airbag statistic, because line graphs, you should not be using a line graph unless you are representing some kind of change over time, right? So this suggests that over time, this goes up and then it comes down and then goes up, right? So line graphs should only be used to represent some kind of change over a period of time, whether that is days or years or seconds or whatever it might be. This chart is not doing that, so the way to represent this data is not as strong as it could be. Instead of this line graph with these no airbag statistics, it would probably be more helpful if they did some kind of double bar graph, perhaps. So where they had, one half of the bar is the airbag, and then the other part here is a different color of the bar with the no airbag statistics as well. However, again, this table is representing that as well. But a bar chart with the double bar graph might be more useful because it can more easily show the visual difference between the two. So imagine for the head, you have this airbag statistic here, and then imagine we had another bar that extended up here that was maybe this pink color. And so that would show you the blue, the blue space would show you kind of quickly and visually how this amount of injury compared to this amount without the airbag. You wouldn't quite get specific numbers without studying the numbers more exactly, but it can provide an information where you're kind of giving a ratio of airbag to no airbag. Okay, so this third example, we have the average number of moderate injuries. This chart's a mess. It's good data. There's a lot of good data here. But again, we have this 3D pie chart, unnecessary. It's all split up. If this was just a 2D and we were just looking at it straight on, it would be much more clear how big each piece was. Let's see. There's also also having the pieces separated like this is not very helpful. Like this white space here is just creating unnecessary dissonance in the chart. Again, this table is just repeating the same data again, so it's just being redundant. And also things like, think about your labeling, right? So tib shaft and tib plat. Those are very scientific terms, and this data is not for scientists. It is for policymakers. So, having things like tib shaft and tib plat is probably not the best way to describe those. It would make the reader have to go do additional research, which would be unnecessary. Okay, so now we come to some better examples. So this is a student example where the student was asking, what career direction do you associate with technical writing? So we have computers, English and teaching, and science, and there was another option here as well, but nobody selected that. So we know the student's total number of responses. The graph is clearly labeled here, again. And we have the percentage of each color represented with the answer that was provided. So, yeah, this is a very strong graph and gives a sense of out of these 16 respondents, how many responded to each, how many responded to each answer. Here's a good example of a bar chart as well. So this has a lot of good data. I like this. She did a good job of including the data point. So technical writing, even though nobody selected that, she still included that on her chart because that's the ethical thing to do, right? You want the reader to know that that was there, even though somebody might argue that that's unnecessary data because there's nothing there to report. It's important for the reader to know that that was an option if you're talking about that in the text. So again, we have 16 total responses, and the bar chart shows clearly, each bar is clearly labeled. The only argument that you might make for this chart is that it could be better rather than percentages to use specific numbers. So, if instead of percentages, if we had 2, 4, 6, 8, 10, 12, all the way up to 16, we could have potentially more specific numbers rather than percentages of what was selected. But other than that, regardless of that, it's still a very strong chart. So this chart is not quite as strong. This chart has a couple of problems. So we see the question up here, do students understand what professional writing is before they take the course? Okay. First of all, what course? And then down here we also have, does professional writing relate to scientific writing? Is it clear in the course description what each class covers and teaches you. So really, this chart is trying to represent probably what should have been 3 different charts. Yeah, at the very least 2 different charts, but probably 3. In addition to that, while the use of color is good, it's clear what is what. We don't see the ordering of these answers. So strongly agree, agree, strongly disagree, disagree, don't know. This is not the best way to order this. So typically when you think of these scales, right, strongly agree is going to be at this end, and strongly disagree will be down here. So it should be strongly disagree, disagree, don't know, agree, strongly agree. Because you want to think of, again, your reader and what their experience is with this chart. They will be used to reading left to right, with left being usually the weakest response, and then the right being the strongest response. Okay, so here's another example. Are advisors helping students in the English major understand what is professional writing? Okay, a good question. But is it one that needs a chart based on these responses? So first of all, there's no labeling, so we don't even know what the responses are or how many people responded. We don't know what the total number of responses was, we don't know what this represents, and we don't know what this is. We know that this is yes, we know that this is no, but we don't know. This could be 1 person, this could be 3 people. We don't know. So in addition to those problems, this doesn't need to be a chart. In general, yes/no questions, things with a strict binary like this, probably will not need to be a chart. So yeah, this is just not a very strong chart. By contrast, however, this is very strong. So this has very good data, and it's a great form. This is probably the perfect form to use for this data. So this student has, unfortunately there is no title, so that is missing. That is a weakness. But each of these bars is clearly labeled, right? So we know what the colors represent over here based on the chart here. It would have been useful if the student had numbered what these are. These are probably the number of students, and it's talking about expertise in each program, right? So this chart over here is great, and unlike the charts that we saw for the traffic reports, this is not repeating this data, right? This is providing more context for these charts. So rather than trying to cram, not experienced, somewhat experienced, experienced onto this chart, the student has provided this easy reference point over here. So this is a very good chart, despite maybe some of the lack of labeling. If there were labels, it would be much, it'd be a perfect chart. There are good labels down here, obviously, and it's easy to tell what each of these programs, how these bars relate to each of these programs. So alright, so this chart, or this table rather, it has a lot of good data, but it's not in a good form. If you think of the bar graph that we just looked at in the last slide, that would have been a much better form for this data. So this person is measuring, basically students' experience with these various social media platforms, but again, we don't know the total number, and we don't know if people responded. We don't know how people responded to each one. It's just, so you can see that this data is very good, but it's just very hard to read, right? So if you think back to the previous chart, it probably would have been much better served in a chart like this, right? You can imagine this data looking like this, right? Not experienced, somewhat experienced, but instead of programs here, we would have the various social media platforms. So this is an example of, great data and data that should be visually represented, but the person didn't choose the right form for the data. So this is an okay chart. It's pretty good. The title could be better. We don't know proficiency percentage of what exactly. The labeling of the colors is good, but the use of this gradient, if you can see it, right? So this person used these gradient colors for the pie chart, which was probably not the best idea for this type of chart, because again, if your reader, might be somewhat colorblind, or if their eyesight is not quite as good, this can begin to look like a different color from this blue, right? So it might not necessarily be clear upon immediate viewing that these are the same side. It almost looks like different colors. So don't use gradient colors in your graphs. Just use strong, bold, single colors. Again, don't try to over design. Just you're thinking about conveying the data to the reader. You're not trying to show off your graph making skills or chart making skills. All right. Our last example again. So here's another example of good data, bad form. This is a line graph. Again, we talked about how a line graph is for looking at changes over time. But these are all individual responses, or static responses rather. So these different percentage points, these are, I'm assuming, percentages. Again, this is not labeled. This percent already knew how to use something. I'm not sure what this person is. There's no title for this chart either, which is another issue. So this percentage already knew how to use. This percentage looks like 0, had to be tutored. Only know enough to get the job done. Are an expert in more or one of something. Again, we don't know more or one of what. So this could be good data. It needs better labeling, and it needs a different form. This would probably be better represented as a pie chart. Because again, the line graph is for changes over time. However, each of these responses are discrete. So using a line chart doesn't make sense. Okay, so I hope those examples were helpful. I know this video is getting a bit long, so I'm going to go ahead and wrap it up. The last thing I want to talk about is your visualization assignment, which you should be using what I just talked about with the examples regarding creating good figures for your visualization assignment that is due on Sunday, June 19th. So for that assignment, you have to create 3 visualizations from your quantitative survey data that you collected from the survey that you just passed out to the class. Those visualizations need to be 3 different forms. So for example, you could do 1 table, 1 bar graph, and 1 pie chart. So it just needs to be, it could be the same data, but it could be in 3 different forms. If you only have 1 point of data that maybe makes sense to put into a chart, you can use that 1 question or that 1 point of data, but you have to represent it in 3 different ways. So when you do that, just remember, again, the labeling, clarity and simplicity of design, and choosing the best form to represent the data. I'd recommend reviewing pages 319 and 320 in the textbook. It does a great job of providing a chart that shows which types of graphs or figures
are probably best for certain types of data. So you can use Microsoft Word or you can use Excel to create the charts and the graphs. Either one's fine, whichever you're more comfortable with. So again, that's the visualization assignment. You can review it in the syllabus if you need, but that is due on June 19th. The last point is that these visualizations will also become part of your recommendation report. In your recommendation report, you will need to include 2 visualizations. And so you want to make sure that they're following all of the guidelines that I've discussed in this video lecture. So if you have any questions, I will be the one reviewing and evaluating your visualizations assignments. So you're welcome to email me directly if you have any questions. Or of course you can email Dr. Richards. My email is mbeal009@odu.edu. That's mbeal009@odu.edu. If you have any questions. My name is Matthew Beal. Thank you for watching. I appreciate it.